Hello, everybody. Thank you for coming. My name is Tony Guimelli, and today we're going to talk about almost, and I'm going to use that word a lot, almost and generally, everything you want us to know about working with JWTs and JWKs, but we're afraid to ask. I'm going to go through my background super quick because I want this to be more of a demonstration than PowerPoint. I've had various cybersecurity roles over the last 15 years or so. Been in IT for 22 years. I've been on the API secure development side, identity and access management, enterprise architecture, security engineering, and throughout all of those roles, I have used PowerShell consistently for the past 12 years. I felt it's a phenomenal tool, not just for offense, but for defense, and today I'm going to cover both of those. But this is largely a presentation about the flaws within JSON Web Tokens, or more specifically, the APIs that consume them. So we're going to break down what JWTs are and what JWKs are. That's JSON Web Tokens and JSON Web Keys, respectively. Common usage patterns amongst them, not all of them, because there's a lot to cover here. So I'm going to go over what you'll mainly see in the cloud space and protocols such as OpenID Connect. A PowerShell module that I've developed that is in the PowerShell gallery. There's a few JWT modules. I think mine's a little different in that it covers things from a more full spectrum perspective. We're going to create tokens. We're going to validate tokens, and then we're going to hack APIs, intentionally vulnerable APIs that are based on some vulnerabilities that we've seen in the wild with some pretty well-known vendors. And after all the gloom and doom and after we break stuff, we're going to talk about how to avoid this in your organization and how you can secure your APIs to not fall prey to some of the more common misconfigurations with JWTs through some best practices. So before I start going through this, I'm not the show of hands guy. Show of hands if you know these terms: OpenID Connect, JSON Web Token, JSON Web Key. Okay. We'll start with so I'm going to minimize the exposition. JSON Web Token, simply put, is a security credential largely used by APIs, and the most important part of it is that it should be digitally signed. Should be being the operative word, because the RFCs actually afford you the ability to generate JSON Web Tokens with no signature, which means they're effectively useless and they're not a security credential. And I'm sure everybody here knows this if you know JWTs, but the purpose of a digital signature is integrity, ensuring that the token has not been altered in transit when it gets to its destination point. So if we take apart what a JWT is, I'm going to go through this fairly quickly because it seems like the majority of you know what this is. A JWT has three what is called parts: a header, payload, and signature. The header denotes cryptographic information as to how the token was signed, which is the single most important part of this presentation. Anytime we have a JWT up on screen, I want you to draw your eyes to the header. For those that can see the colors, the header is in red, the payload is in blue, and the signature is in green. Now, why they're called JSON Web Tokens is when we decode the header and the payload, we have two JSON blocks. As we can see here, the header, it's showing what's called a key identifier. This is what the key that was used to sign it, and it's of type JWT. And the algorithm in this case is RSA SHA-256, which means that there's an asymmetrically signed token. The payload contains a lot of stuff, but we're not going to spend as much time on that today. The payload contains these things called claims. Claims about what? Claims about authentication and authorization for the party that had requested it from the identity provider. So in this case, I'm the subject. And if we roll our eyes down a little bit, we can say I have a role of presenter, so authentication and authorization. There's also some claims about date ranges in here. Starting from the top, we see EXP, that's expiration in epoch time. We're going to reverse that to systems.date time in a little bit. IAT is issued at, and NBF is not before. IAT and NBF generally are the starting point. One or both of those is the starting point for your expiration, and then EXP is the bookend to that. And we also have a unique identifier called JTI, which uniquely identifies the token and then the signature. Now, when we are talking about JWTs, the topic always has to come up in terms of signing the token. So the response to token signing is token verification. And a key used to verify the token, generally speaking, is a public key, generally speaking, expressed as something called a JSON Web Key. Now, the specification for the JSON Web Key, RFC 7517, gives you all sorts of flexibility to do all kinds of weird things, like symmetrically signed keys, that means shared keys, like private keys. But when we look at something like OpenID Connect and OAuth 2.0 in cloud identity, you will generally see a JSON Web Key only largely represent the public key. So the identity provider signs the JSON Web Token with its private key and then publishes a public key, which is effectively a public key serialized as JSON in the form of a JSON Web Key. And it is typically retrieved at the identity provider in something called a JSON Web Key set. Now, in this case, I only have a single key in the set, but we can see based on the JSON array that you can have multiple keys in the set that are uniquely identified by something called a key identifier. And in this case, this is a pretty typical JSON Web Key. Key type, KTY, is RSA. Its usage is signature, and there's the exponent and modulus. And generally speaking, what you'll see on the identity provider side is that they'll have multiple keys in a set for rollover, because certificate rollover is always an issue that has caused outages for many of us over the years. So pretty typical flow in OpenID Connect. Client is using an application, and that application calls backend APIs, be it REST API, Graph, GraphQL. The client has to authenticate to the identity provider. They authenticate successfully to the identity provider in step 1. Step 2, the identity provider issues them a JSON Web Token. At this point, the client application now has the JSON Web Token in its possession. Maybe a React app will likely post that to the API endpoint. Now, at this point, the API endpoint has two things it can do, two potential options, maybe more. The two most common options are the API endpoint has the public key on its backend and it verifies the signature. That is step 1 of the total validation process. It is the single most important part, is the most of what this conversation is going to be about today, but it is step 1, and what it will do is either pull the public key on its backend and verify the signature, but we know that certificates expire and there needs to be a process to manage that out of band, or the more hip way is that it's going to reach back out to the identity provider, having a high degree of assurance that it is going to the right space, and saying, hey, give me this JSON Web Key, which is in that JSON Web Key set that we saw prior. The identity provider returns that JSON Web Key set to them, and then the process of signature verification commences. And the process for validating a token should look something like this. And if any of these steps fail, the token should not be validated. Step 1, signature verification. Generally, private key, public key, signed by the private key, validated with a public key. Step 2, is the token still in date range? Has it expired or not? Step 3, did it come from the right place, the right issuer? Step 4, is it going to the right target, the right audience, the right API? And then after all that's done, that we can crack open the token, take a look inside, and determine what access the user has to the data in question. And I'm going to, for questions, once we get to the demo, I'll take questions toward the end of that. So, a long time ago, in a galaxy not so far away, at my prior organization, I was a mobile API developer dealing with secure APIs, secure API development. And I left that team to go over to play a role of more of an identity engineer. And when I left the team, all of a sudden there was API sprawl, there was identity provider sprawl, and there was environment sprawl. And the common thing I heard from developers coming over to my desk every day was, almost every day, was this JSON Web Token should work with this API, should being the operative word. So the first thing I was thinking was I wanted some tooling to be able to crack open the token to determine what it looked like inside, convert some of these values to something that I could actually understand. And once I got to that point, I was thinking, it'd be really good if I could play the role of the backend API. If I could basically function as the API in a test harness capacity to figure out diagnostically why this is breaking. And then after all that was done, I'm like, okay, well, I can decode the token, I can validate the token, might as well create, might as well build a whole round trip. The module was born, and I left it at that, which is surprising because as far as being a cybersecurity person, I think the only real difference between a cybersecurity person and a typical engineer is pessimism. And I didn't really see too many holes that I think would be exploited in JWTs until I'd seen a presentation by B.B. King, not the guitar player, from Black Hills Information Security, where he was talking about on live penetration tests, so not hack the box, not tryhackme.com, but actual penetration tests where he saw all these ridiculous things happen with JWTs. And it surprised me that this had eluded me, but I was looking at one of the commandlets in my module called New JSON Web Token, and I was thinking if I just juiced that up a little bit, then I could use this in an offensive security context. When I say offensive security, for those of you who don't know, I mean penetration testing, so ethical hacking. And the beauty of PowerShell is that I can run these commands interactively, or I can run them non-interactively in a test harness if I wrap it with Pester. Thus, the module was born. So let's start from the beginning with creating a JSON Web Token. I just spin up my environment. Give me 1 second. We're going to get a few errors. My Azure functions tend to go to sleep, so we're going to give a little kickstart. Can everybody in the back see this okay? The console, letters, such? Okay. First parts of the demo are going to be just bare bones creation of a token and decoding a token in various ways. So starting from the beginning, I'm going to generate a JSON Web Token with a certificate. So let's take a look at what that looks like. Clear that out. Okay, in this example, the center point of this example is new JSON Web Token. But what we can see I'm doing here is I'm using getPFX certificate, not mine, comes with a PowerShell, I think the security module. I'm obtaining a PFX file and loading that into memory as what's called a .NET X509 Certificate 2 object. And because it has a private key, I need to pass a password from it, which I'm pulling from the secret store. The parts that are relevant to this demonstration are here. I'm establishing a claim set, and my module is heavily dependent on hash tables. I wanted to make it as native PowerShell as possible. When I've done this with C# in the past, I've used dictionaries. But our claim set to start with, I'm just going to have two simple claims of subject and presenter, me as the subject and my role of presenter. So I'm the authenticable principal, and my role is presenter. And I'm passing that claim set to new JSON Web Token. I'm passing that PFX, that .NET X509 Certificate 2 object, and I'm giving that time to live of 300 seconds, which is 5 minutes. And now I'm going to pipe that to show decoded JWT, and it's going to look something like this. Hate to do this again, another show of hands. Who here has used JWT.ms? Who here has used JWT.io? You feel comfortable sending your tokens over the internet? You sure you're not being man-in-the-middled? Use this. This is developed for that purpose. I know I'm not supposed to be using RightHost. I heard the whole spiel about it many years. I haven't touched it literally until this year. I wanted to replicate that look in there to make it so that we're not sending our tokens over the internet without knowing if you're being man-in-the-middle. And by the way, if you want to know if you're being man-in-the-middle, you should have came to my talk yesterday where I was showing you how to determine that. So this is show decoded JWT, and we can, or the result of show decoded JWT from what was created with new JSON Web Token. And what I have here is a token that is signed with a key identifier beginning with H8S. We can see it's an RSA signed token. And we can see in the payload, the part that's in cyan, for those of you that can see it, that I only passed 2 claims to it of subject and role, but there's 5 claims total because the new JSON Web Token function by itself will intrinsically, unless you tell it otherwise, and we can do that. And I have all the help documented in my README and also on the individual functions themselves. It threw in 3 date range claims for IAT, NBF, and EXP. $10 for anybody that can tell me what EXP means in this case, like what that actually amounts to. So what we're going to do is switch to a different commandlet to look at the output called convert from encoded JSON Web Token. This one's a little more objecty. On which one? On Visual Studio Code? Not a problem. So let's run it again. Now we get different output. So I have a class that I'm filling in with these values. I'm reversing what's called the key identifier in the header to the X509 certificate thumbprint value, and I'm getting UTC time, system.date time, for not before issued at and expiration, which are NBF, IAT, and EXP in the payload respectively, and then I'm just returning the other things as strings. So what this is telling me right now is that, and that's UTC time. I know it's not 10:29 here right now, but we can see it has a 5-minute interval. The other decode methods that we have, I'll just go through one of them, are get JSON Web Token payload and get JSON Web Token header, which this one becomes relevant later when I want to craft a malicious token, where this will just basically crack open the payload and get JSON Web Token header. We'll crack open the header and return them as hash tables, but there's also some options to return them as strings. So that's create and decode. Now, we're going to validate a JWT against the public key. So pretty typical use case. I have a backend API. I have an API, and on the backend that has possession of the public key. So let's take a look at what that looks like. So this script effectively performs two roles. It's live action role playing as both the identity provider and the service provider. So from the top, get PFX certificate. I'm getting an actual certificate with a private key. Get PFX certificate will also get a certificate that only has a public key. So in this case, I'm getting the private key and the public key. Claim set again, nothing different there. I'm generating the token. Everything above the clear host line, which is line 13 if you can see it, but everything above clear host is me playing the role of identity provider. Below that, I'm playing the role of the service provider. So in this case, I'm now taking the token that I've generated and I'm validating it against the public key that corresponds to it. And of course it will work because it's all coming from the same place, but this is demonstrating the round trip. So what test.json web token allows us to do, I'm gonna show it to you with and without this, give me 1 second. Test.json web token returns a Boolean. Doesn't really tell you that much until we call the verbose switch on it. And we can see the identifier for the signing key, so it's interrogating the header, is whatever that value is. It begins in H8S for anybody who can't see that. I can barely see it. Signature was verified, the date range is valid, and therefore it is true. All of those steps have to pass. So if I were to, as an example, say, give it a time to live of 1 second, and we're gonna take a 2-second nap. We're gonna see it's gonna return false, but it's gonna tell you why. Signature's still good, JWT is expired, ergo it is false. So that's generation of a JSON web token, signing with a private key, validating with an X509 public key. Now the more common way to do this against the JWK set. So in this example, I have an Azure function that I've coded. Actually, let's go here first. We want to establish a JSON web key set. What's the way to do it? New JSON web key set. So I'm going to take that exact same certificate, pipe it to new JSON web key set, and it's going to produce me a JSON web key set. I don't know if you guys can see that at the bottom. But basically, it's a single key in a set. We have the ability to put multiple keys in the set, but for purposes of this demo, I'm going to generate a single key in a set, and we can stuff that out in a web endpoint with an Azure function as an example. If we wanted to write REST APIs in PowerShell, we have the capability of doing that. I'm pulling the public key from this is an Azure function backend code. I'm pulling the public key from my environment variables, and then again, PFX certificate, I'm obtaining it differently here in the Azure function. I'm generating an X509 certificate 2 object, which will work the same way. And what I'm going to return is that certificate piped to new JSON web key set, and there is a compress option on it. So when we go back to the script that has that validation endpoint, what it returns is going to be, go away, smiley faces. It's going to be this. So now, test.json web token also affords me the ability to test against the JSON web key set, not just the public key. So same premise as before, except this time we're going to add another piece of validation, the issuer, where it came from. Again, same certificate, the same private key password. Now I'm adding issuer to the claim set. So I'm the identity provider. This is where it's coming from. I need to stop hitting my mic. And I'm going to generate a token with that payload. Oh, and by the way, the hash algorithm SHA-256, that is default. It can go to SHA-384 and SHA-512, but I'm putting in there to be a little more explicit. There's a lot of parameters here, so if you're checking out this module, run help on everything. So we have my JSON web key set URI. Now test.json web token has a parameter called JWK URI, which I feed in that URI. We're going to run it with verbose, and I'm going to do it in the console so you'll be able to see a little better. And we get a lot of info now when we run verbose off of this. And again, we can just kill the verbose switch and not get any of this, but the first thing is it's interrogating the header to determine what the KID was. It's making a REST call out to the JSON web key set URL that it was passed. And this is the part that's interesting. the JWT header contains key identifier that corresponds with the following key identifier in the JWK set. So there's a match. In other words, the header has a KID of X. It is signed with a KID of X. There's a JSON web key with that key identifier. Now, signature verification. Now it's attempting signature verification, as it says, attempting signature verification. There can be a match on those KIDs, but we still need to perform signature verification to ensure that it has not been altered in transit. And lo and behold, there's much rejoicing. Verified signature against the following JSON web key, and I'm being super verbose and dumping the entire JSON string. Signature was verified. We already know this. Date range is valid. Token issuer validated. So that's the other check we have in here. We also have the ability to add audience as well and have a test against that, which would be the total round trip of signature, expiration, issuer, audience, then the payload itself. So this goes back to that graphic I had before, where token is generated, the validation endpoint then reaches out to the identity provider, obtains the JSON web key set, and verifies the signature against that. Okay, now onto the real stuff. Quick show of hands here. Has anybody any experience in penetration testing against APIs that are using JSON web tokens? Are there any pen testers in the room who have done this sort of stuff? I find it very illuminating when I've taught. I don't want to throw any vendors under the bus, but I find it very illuminating. I really want to. No, I'm kidding. I find it very illuminating when I've had to speak to vendors in explicit detail as to how to attack an API with this sort of stuff, especially considering that the RFC tells you, if you explore the RFCs, RFC 7519 and 715 for JWT and JWS respectively, and 7517 for JSON web keys, you're going to find a plethora of really, really, really weird stuff. Like, for example, JSON web tokens don't have to be signed. Per the RFC, they do not have to be signed. That ALG claim that I want you to focus on, there's something called an ALG of none. And what does that look like? We can generate a JSON web key with an algorithm of literally nothing, and it will be header.payload.nothing, and that is a syntactically, there needs to be that trailing dot, that is a syntactically valid JSON web token. And what you're gonna see, I'm going to spoil the end of this presentation a little bit, is that validation engines, several validation engines, including the one by Cisco, Node Jose, will actually follow the RFC to a fault. Meaning, if I have a token that is not signed, it's like, okay, that's fine. I'll just pass it right through. We're good. I don't have to do anything with it. You're authenticated because you didn't ask me to verify the signature. So let's take a peek what that looks like. And by the way, if you think I'm just like making this stuff up, this is stuff I've seen on Hack the Box and Try Hack Me. I've got some really depressing news for you at the end of this. No offense to anybody employed by the companies. I'm not throwing any companies under the bus. This is just illuminating the first time I'd seen this. So in this case, we're going to test an attack called the non-algorithm attack, or the signature stripping attack against an endpoint that I developed. This is my validate JWT endpoint. Before we do that, we're going to just we're going to send this validate JWT endpoint that I've developed is effectively it's pretending that it's an API that will receive a JWT, so it receives a JWT and then it's like, okay, you're authenticated, then I'm going to do stuff. But in this case, all it's going to do is tell me I'm authenticated or not. So let's just do here's our positive use case first, nothing super interesting. I don't know if you can see that down there, but it's saying status is authenticated and it's returning the payload. So basically, yes, this party is authenticated, will return the payload. And I want to just step through that code very, very, very briefly. This is me trying to represent what an API would look like, and I've written these in C#, I've written them in Node.js, TypeScript, JavaScript, I've written them in Python. I wanted to have us stay all on the same page today. I'm not saying go write your APIs in PowerShell, I just wanted us to speak one language at this point. So this endpoint is a typical API endpoint that will receive a JSON web token. On its back end, I have the issuer, audience, the URI for the JWK set, the issuer and the audience. So we're going to take a look at how I'm doing this with test JSON web token. So I post this to the endpoint, like so. I'm using a authorization header, so I'm sending a bearer token over. I'm playing the role of identity provider here, and service provider is this endpoint that I'm hitting. So I generate a JSON web token, exactly what I did in the prior examples, except this time I'm crafting an authorization header with a bearer token inside of it. The URI and the audience are one and the same. So on the back end, I am validating against the JWK URI for the signature, the issuer and the audience. And if we drill into the code, if we have a bearer token, these are the only allowed algorithms. RS-256, RS-384, RS-512. That's RSA SHA 256, 384, 512, respectively. In other words, asymmetric algorithms, no symmetric algorithms, no HMAC algorithms, and no none. So if the algorithm is good, it's in our whitelist, then I will, if it's in our allow list, then we know the test JSON web token returns a Boolean, and I'm testing against, this is the full round trip of what this can do in terms of all of the things we can validate against. I take the token against that algorithm, against this JWK URI, as we've seen before, and against the issuer and the audience. And if it bombs, do not pass go, do not collect $200. But if it's good, then we're off to the races. So if I were to, for example, go to that same API and pass a JWT that has literally no signature, as denoted by this no signature parameter, this JWT is going to have header.payload.nothing. It's going to live for 10 minutes, 600 seconds. This will bomb, because I'm not following the RFC to a fault. Now, if we were to, I don't know, validate the JWT incorrectly, it's always a dead giveaway for a bad API endpoint, we're going to see this. And why am I authenticated with no? So first off, let's take apart that token. Actually, it's probably going to be easier for me to do here. This is what a typical signature stripping attack looks like on a JWT. This is JWT no sig. Let's go with the old reliable. Alg of none, all lowercase. Please pay attention to that for the conclusion of this mess. So I have a JWT, a structurally valid JWT per RFC 7519. No signature. Payload is good, and you can see that trailing dot in yellow at the bottom. So if I were to post that against validate JWT incorrectly, I'm in like Flynn. And why is that? Because, and this is my attempt to replicate what I've seen with the libraries that are vulnerable to this, we get the authorization header. If the JWT header.alg, the algorithm claim, is not equal to none, then do stuff. Else if it is equal to none, you're totally fine. Just pass right through. No signature needed. It's only going to attempt to validate the signature if it's told to. The big takeaway from everything I'm discussing today is this, and I'm going to get to this in very explicit detail in a little bit. The header will tell you how the token is signed. Do not look at a header for validation instructions on your APIs. As a matter of fact, look at the things that you're using for, if you're using PyJWT, take a good look at how these function to make sure that you're not looking at the header, decoding it, and saying, oh, I'm going to validate it this way. All your validation configuration should be on your back end. So in this case, because it's an alg of none, it's skipping the actual signature verification pieces. Now, but wait, there's more terrible things. So in regard to the specification, if you start looking at, I believe it's RFC 7515, which is the JWS spec, and this is kind of a misnomer. There can be unsigned JWTs, but a JWT that has a signature is also considered a JWT, despite the specification for signed JWTs being JWS. In any event, the header can have many, many, many attributes, and one of those attributes is the public key expressed as something called the JSON web key. And a company you might have heard of, a small company called Cisco Systems, they have a product called WebEx. They had a library called Node.Jose. And there's a CVE 20180114, and it worked something like this. I am Joe Attacker. I have my own OpenSSL cert that I've generated with a private key and public key pairing. I can generate my own JWT using any library that I want. Now, what I'm going to do is override the backend instructions by stuffing the JWK in the header. So it works like this. I have a backend that says, go to this JWK URI unless there's something in the header that says, oh, there's stuff here, I'm just going to validate against that. Thank you for that. And how that looks is this. We're going to do it with and without. And I'm going to bring it up on the console so you can all see it better. So in short, nothing up my sleeve. There's no JWK in the header yet. We're going to run that. and even validate incorrectly is going to effectively reject this. Because what I'm doing here, this function, this is not in the module, this is just some stupid thing that I wrote. New signing certificate is effectively a wrapper for the OpenSSL libraries. When I run this, it creates a PFX live. So this cert didn't exist until I just clicked that. So I'm sending 2 messages out. Access is denied because it has no idea what the cert is. I mean, I don't even have an idea what the cert is because I literally just created it when I hit enter. And the token we can see looks like what you'd expect, and it's being rejected at that other side. So try doing this quickly in Burp Suite, by the way, which is the tool that a lot of people will use for JWT exploitation with their plugins. I'm just going to simply state include JWK. That's it. Now it's going to be in the header. And what that's going to look like is this. So the header got a lot beefier. For those that can see the colors, red is the header. The JWK is in the header along with the other attributes. So not only do I have the cryptographic information as to how it's signed, I have the actual public key stuffed in the header serialized as JSON. This is one of the claims that can be used to override a backend. And why it's doing this, again, this is me LARPing as an API in this case, but if we take a peek at validating correctly, what is going on here? Well, header contains JWK is intrinsically false. If the header contains a JWK, then grab it. And we're in this logic here. And by the way, this is, if you look at the code for Node.jose for CVE 2018-0114, you're going to see something very similar to this. I wanted to make this as clean as possible for understandability. But if the header contains the JWK, we're going to validate it using test.json web token, but against what? Not against the URI, against the JWK in the header. Test.json web token can validate against a JWK URI or just a JWK itself, not a set or a public key or an HMAC key. There's multiple options. Now, if the header doesn't contain a JWK, then take the happy path or the more intelligent path, which is going to the URI. And where's this URI configured? That URI is configured on the backend. But that's not the end of it. This is one, my daughter gave me the name for this one. We thought it was hilarious. It's called Everything Bagel. So off the top of my head, this is going to contain at least 5 attacks that have been pretty well documented. But first off, we know, and it's all header. This is all going to the header. We don't even look at the payload. First off, we're going to stuff a JWK in the header. Then I'm using splatting here. I was going to try to do it in one line, but it went off to the side of the screen because bragging about doing something in one line gives you more PowerShell cred, I guess. But I'm splatting it to make it more readable and better. But this is still faster than Burp Suite, I promise. We're going to stuff the a JSON web key in the header. That's the key itself. We're then going to annotate the header with what's called a JKU claim, which is the URI to a JWK set. We are also going to stuff the entire X509 certificate chain in a claim called X5C. By the way, these are all in the RFC. This is all above board per the RFC. And then finally, if none of those work, we're going to have another URI to an X509 certificate endpoint that has the public keys expressed as PEMs. So in other words, not JSON web keys. And to make matters worse, add insult to injury, evidently with that key identifier thing that I told you about, and I've never seen this myself, but supposedly some validation engines were, or maybe still are, vulnerable to directory traversal attacks. So the way that this whole mess works, I have my new JWT params that I'm going to pass the new JSON web token. You've seen me do the claims before, you've seen me do the start, we're not going to belabor that. I'm going to include the JWK, that's a switch parameter. I'm going to include the X509 certificate chain, that is a switch parameter. I'm going to include the JWK URI, that is a system.uri, not string. I'm going to include the X509 URI, another system.uri. I'm going to use custom key identifier, which then affords me the ability to override the KID with something that I specify, which in this case is demonstration of a directory reversal attack. I'm giving it a TTL of some I don't even know what that is. I think that's like 6 months or something, but like I can make this whatever I want. And the end state of that is going to look like, it looks hilarious because it's so top heavy. The header is like this and the payload's like this. But let's take a peek at it. Oh, I should know the name of this. And Everything Bagel is going to show, oh, sorry, most important part. This is also fun. Capture JWT, I'm not generating one from the ether. I've obtained a JWT prior, we'll assume for purposes of the attack, through man in the middle, somebody passing it to a proxy. So I have a JWT, and I want to preserve the existing payload. I don't want to rewrite all that stuff. The payload on this thing is monstrous. I got it from an OpenID Connect endpoint. Enter get JSON web token payload, which by default, when you pass a JWT to it, will return you the payload of the JWT as a hash table. And isn't that convenient because that is what is passed to the claims parameter on new JSON web token. It's reciprocal, I think. Everything ties together. So grab the token, obtain the payload, generate your own signature for it. And the fun part about this is this token expired months ago. When I pass my own TTL to it, it will eradicate the date range claims and put my claims in place of it. Now, we run this monstrosity. This is the header where we can see the X5C. Here's the base 64 encoded. I mean, this isn't going to raise any alarms for anybody that's looking at your logs or anything, right? But here's the X5C, the base 64 Earl encoded cert. The KID is now this directory traversal attack. Your algorithm is still the same. Here's your JKU. Here is your X5U, which looks something like this. By the way, my module also will do this. I have an Azure function that does that. That's a PEM. And here's your JWK. And the header now has all of that stuff. Now, if we were to look at the date range, just we know that this token, trust me, this token expired a long time ago. I just generated it. So I'm overriding the date. Sorry, convert from encoded. I don't know the name of my own stuff. Run it again. Let's take a peek at the date ranges. And I'm giving it, I guess it's not that long. I gave it a full day, but I could make it as long as I want. So at the end of it all, there's a lot of things that can be broken here. I'm going to jump back to the slides for a second, then I want to take some questions. So some of this sounds pretty ridiculous, like who would ever do these sort of things? This is Okta. Okta fell prey to this, and Okta, no offense, because I know that some of you are here, Okta has some really, really, really good documentation on why to avoid the non-algorithm attack, and you probably can't see that, but what that header is showing is alg of lowercase non and capital E, because Okta was very, very good about doing a case-sensitive search for the non-algorithm, but if you were to uppercase one of those letters, it sails right through, and then you have an empty key identifier as well. So this afforded a threat actor to send a token to Okta, an identity as a service provider, and it would sail right through, bypassing authentication and authorization completely. This is the roll your own portion of this. I'm showing you a small smattering of what this module can actually do. So new JSON Web Token is basically the Swiss Army knife of creating these tokens, but there's other ways that we can do this as well, where, if I can see it in my own, oh, here it is. So I'm not using new JSON Web Token here. I have another commandlet, and yes, I'm using the term commandlet. It's an advanced function, but I just like that. I'm using the term, I'm using this function, commandlet, convert to JWT part, which is what was private to my module prior, but I wanted people to have the ability to generate whatever they want. If you have any experience with what's called a JSON deserialization attack, test JSON Web Token won't let you just pump in whatever, but what you can do in this case is build a hash table of whatever you want, inject all the nasty stuff you want, convert it to JWT part, and join it. All convert JWT part does, it just gives you some speed in this case where it serializes the hash table as JSON, compresses it, and base64 Earl encodes it. That's what a JWT part is. It is a key value pair as compressed JSON, base64 Earl encoded. So I'm building a header from the ether where I'm saying the type is JWT, alg is none, and the KID is literally nothing. I'm building my own payload. I have some other functions in the module for datetime. I can convert epoch to datetime and datetime to epoch. So I'm the subject, I'm the role of hacker person, issued at EXP, and I'm giving it a new JTI, and I'm converting it, and I'm building it as such. And what that is going to look like, and this is in time permitting. The token looks like this. No signature, trailing. This would have, I believe, Okta got hit with this in 2020. This would have passed right through to them. And last but not least, before I get to questions, looks like I do have time, so I want to talk about this. Has anybody here, one more show of hands, I promise this will be the last one, experience with HMAC signed JWTs? That's a really good answer. Don't, just don't.
Some APIs require
Ew. You lose non-repudiation in that you don't have, so let's put it this way. I'm an identity provider. My friend Rob over here is a service provider. I send him a token. I sign with a private key. Rob accepts it, and he validates with a public key, and there's much rejoicing in the world. I have one attack surface at that point, and that is because the bad person will always want to get your private keys. They want to get your domain admin creds. They want to get your admin creds in Azure. They want to get your private keys. When you're dealing with HMAC signed JWTs, this is a symmetric algorithm, meaning the same key that signs is the same key that verifies, and what could possibly go wrong with that? Even if you don't have any issue with the audience accepting this JWT, the problem is you implicitly lose non-repudiation because the same key that signs is the same key that verifies. Now, being a security person, again, the thing that separates me from other DevOps people is that I'm a pessimist by default, by trade. You will have an attack surface that's split across at least two parties. So one of the things you're going to see with HMAC signed secrets, and I'd like to believe that this is only a thing that happens in make pretend land and like hack the box and try hack me, but if you're generating a secret, which is a string for your HMAC signed JWTs using some basic words, they can be brute forced, and this is an offline attack, meaning I get an HMAC signed JWT, I believe that the identity provider has done something foolish like sign it with a password of password. I can then feed that into a word list and break it open. So in this case, and by the way, this only exists in my module for pen testing purposes. I would never in a million years espouse using HMAC for production. But in this case, same thing as before, I'm generating a claim set. I don't have a private key anymore. My secret is secret, and I'm generating a new JWT. When I call the key parameter, that implies HMAC out of the gate. So instead of us being RS-256, it's going to be HS-256. I'm giving it a time to live of 10 minutes, and I have a word list file that I'm going to feed it in against, and that's going to reflect something like, if I can remember the names of my scripts. Oh, HMAC brute force, there we go. Tested 1 of 100, blah, 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 iterates through and gets it. Obviously, if you are going to use HMAC, which you shouldn't anyway, and you should feel very terrible if you do, but if you don't, then you would use something like a HashiCorp Vault and a keyless or something that's going to generate some really, really long, ridiculous string and make it not brute forceable, make it non-deterministic. I mean, end of the day, you can probably get away with this, and I've seen HMAC signed JWTs in all seriousness being used when the, I want to say the party, but the organization has control of both ends. It's like something internal, and you have some process. So you basically have an identity provider and audience that's behind your, that's not public to anybody. And then there's a key management engine that both of these things tie into to sync that. But other than that, I mean, private key, public key pairings are free. I mean, I generated 4 just in my talk to you today. I didn't get charged, but at least that I know of with OpenSSL, and you can do the same thing in .NET. Just use private key, public key pairings, please. It's just not worth it. And I think, oh, last one. So anybody here, all right, last show of hands, I swear. GraphQL. Anybody use the PS GraphQL module? That's mine. I didn't want to demo it here because it has way more downloads than the JWT one, and I just think that the JWT one is just overall more impressive. But if endpoints also will take, GraphQL endpoints will typically take an authorization bearer token. So instead of invoke REST method as we've seen prior, I'm doing it with invoke GraphQL query. There's no hack, there's no exploit here. This is just an example that's on my, my repo for PS GraphQL. So same premise. I've used these two modules in concert to test GraphQL engines, Apollo and Hasra, both great products. So yeah, REST, GraphQL, and that is, I could go on forever because I got like a ton of other things to show you, but I really would like to take questions if you all have any. All good? All right, I got one more then. All right, anybody know what that Kubernetes thing is? I've heard that's like, I've heard it's like important. So let's get out of this for a second. So what I found out with Kubernetes is up to if you were to create secrets by default in Kubernetes without being specific about it, it will create them as JSON Web Tokens, and they will not have expiration, which is a problem because if somebody were to, if you don't really have your Kubernetes infrastructure well guarded and you're using RBAC properly, and somebody were to obtain your JSON Web Tokens that are in your Kubernetes cluster, they're going to post your API and they're going to do it endlessly. There is no expiration. Now, there are tools that will afford you the ability to have ephemeral secrets in Kubernetes, but this is a by default. I have a Kubernetes infrastructure, I'm building it myself, and I'm gonna create a secret. And most people won't even bother looking at those sort of things. So let's go into part 1. I have a script called Decode Kubernetes Secrets that uses, for those of you that don't know Kubernetes, Kube control, kube cuddle, depending on, there's always wars about how to pronounce this, but this is basically a thing that allows you to interact with the Kubernetes API. I'm obtaining my secrets from my little Kubernetes cluster, which is Minikube on this computer. I'm outputting as JSON, so I want to traverse this. I'm going to deserialize it with convert from JSON, then I'm indexing in items data token, and these two are mine on this line over here. I'm going to convert the result of that base 64 Erlang encoded string, then I'm going to pass it to convert from an encoded JSON web token. Kind of weird in Kubernetes. There's probably a reason. I'm sure there's a really good reason for this. But we look at a JWT, it's header.payload.signature, and those parts are 3 separate base 64 Erlang encoded strings. What Kubernetes does is take that whole thing that's already has the 3 parts base 64 Erlang encoded, then encodes it again in totality for some reason. So I'm going to base 64 Erlang code decode that whole thing. Then I'm going to pipe that to convert from encoded JSON web token like I showed you before. And I'm going to exclude the signature because if this were an audit thing, we wouldn't, don't persist signatures. Do not store a full JWT because in most cases they are replayable. So I'll just run this. And we can see with the secret I created yesterday, there's no expiration. That's why it's not coming up as a property here. It just doesn't exist. You have to be explicit about this. And I think I'm on version 1.26 of Kubernetes. I'd have to check for Minikube. I might be wrong, but I'm pretty sure it's not the latest version, but it's pretty close to the latest version. So this is all very terrible, and we should all be very scared right now. So this is Okta. This is Cisco. This affected WebEx, not any of the other major Cisco products. So this isn't like fantasy stuff. What to do? The one thing to do is this. There's a bunch of don'ts. First off, verify your signature and do not use the header for validation instructions under any circumstances. Do not blindly follow X5U, X5C, JWK, JWK URI. Don't. Have all that configured on your backend, all of it. The slight corollary to this is the key identifier in terms of I've got a job that's signed with X, I have a JWT signed with X, just so you can do the matching and saying, okay, this was signed with this JWK is the thing I'm going to verify against, but that's it. But don't look to the header for validation instructions. Let it give you a clue as to what the token was signed with, but don't look to it to basically, hey, I'm going to make this leap to this thing to verify the signature, because you're effectively putting all of the data, you're giving the attacker so much power at that point. Verify expiration. Expiration, in a perfect world, it'd be you do with all 3 of these attributes. At a minimum, EXP. If you have IAT and EXP, establish a date range between them. NBF and EXP you might want to use instead because per the RFC, NBF is skewable in the past to accommodate for time sync issues. You cannot skew the IAT in the past per the RFC. I told us not to validate it to follow the RFC to a fault, but here I am doing that. So generally speaking, it's either IAT to EXP or NBF to EXP. Validate JWTs at every endpoint. I can't stress this enough. Do not assume that because you're doing something really cool on your Azure App Gateway or any API gateway that you don't, and that's the proxy to your API, that you're all good. There's multiple pathways into your stuff, whether you know it or not, they exist. Validate JWTs at every endpoint. You don't get charged. It's not a computationally expensive operation. It should be quick. Zero trust methodology is validated at every endpoint. This is a where you can. So the JTI claim is a unique identifier for the token, and when you can, and you will not be able to do this a lot, if you can enforce one-time use tokens with your JOTs do, so that means the identity provider annotates your token with this thing called the JTI. It comes into the service provider endpoint, and you say, hey, has this subject, Tony, ever authenticated using a token with this identifier before? So you have to maintain a database on the back. If so, reject immediately. That is cool for long-running processes. I've seen instances where there's some async architectures that I had to deal with in my prior organization where the token had to live for 48 hours, which nearly gave me an aneurysm. But we can make it, so if we have super long-running tokens, then we apply control elsewhere where it can only be used one time. So if it is hijacked, it can only be used once, which is still bad, but once is better than repeatedly blasting it out. Employ token revocation processes if possible. Long one to go into, this would be for refresh tokens, which is the token that gets you a token. And oh yeah, you should test your API endpoints with this. What's super cool about PowerShell, and one of the things I love about it is, yes, we can run these things interactively, but what I've done with this, and I didn't get a chance to demo it today because it would have taken me well over 45 minutes, wrap this in, I'm sure everybody here knows what pester is. If you don't, please learn that like ASAP, if not sooner. Take the commands that I've showed, wrap them in pester, stuff them into your pipelines, and use that as gates. And that is it. I'm Tony Guimelli. That is my module. And also check out PSTCPIP if you want to make sure you're not being man in the middle, and or just basically determine the security posture of your endpoints. And PS GraphQL is the other one if you want a PowerShell GraphQL client. And I promise that QR code only goes to the PS JSON Web Token one, no other bad places. So, any questions? Comments? Thank you.